In the town of Gwalior in central India, there is a small temple, and carved into its stone is a notice about a flower garden. It dates to 876 CE. It records that the local people gave a piece of land to the temple, a garden 270 units long, and undertook to supply 50 garlands of flowers every day, in perpetuity, for the worship of the god. It is an unremarkable document. Land grants like it were carved by the thousand, all over the medieval world, and nobody has ever read this one for its literary qualities. It is famous for two small circles, the one in 270 and the one in 50. They are the oldest zeros in India that no scholar disputes. Not the oldest that exist, we will come to the argument about that, but the oldest whose date nobody quarrels with. And there they sit, doing exactly what a zero does, holding open an empty column so that a 2 and a 7 can mean 270, in a routine municipal record about a garden and some flowers. You have to like that. The most consequential symbol ever invented shows up, on the record, in a piece of local paperwork about the daily flower delivery. But the little circle on that stone is not really the achievement, and I want to be careful here, because this is the point where the popular story of zero usually goes soft. That circle is a placeholder. It is a mark that holds a column open. And a placeholder, as we have already seen, was not new. The Babylonians eventually improvised one, wedging a sign into the gaps in the middle of their numbers. The Chinese had one that worked better than anybody's, a blank patch of table, unmistakable, framed by rods that told you which house you were standing in. The placeholder is the easy half. Everybody who built a place value system eventually needed one, and everybody eventually got one, because without it your notation cannot tell the difference between 25 and 205. The hard half, the half nobody had managed in 3,000 years of written arithmetic, was to take that emptiness off the counting board, hand it a name, and let it walk into the community of numbers as a citizen with rights and obligations. Not a gap in the notation. A number. Something you can add to, subtract from, multiply by, reason about, and if you are feeling reckless, divide by. That step was taken in India. And the man who took it most decisively did it in the year 628, in a book about astronomy in the 18th chapter in Sanskrit verse. First, though, sit with how strange the step is, because familiarity has stolen it from you. What is a number for? Ask anyone, and the answer that comes back is counting. Numbers tell you how many. 3 sheep, 7 days, 50 garlands. That is what number is. It is the answer to the question how many. Now, what does zero count? You cannot point to 0 sheep. There is no collection of 0 things sitting in a field for you to gesture at. There is only the field. To say there are 0 sheep here is to say something about sheep, while pointing at an absence of them. And for most of human history, that was not felt to be a statement of quantity at all. It was a statement that the question did not apply. You do not count what is not there. You simply say there is nothing, and move on with your day. The Greek objection was sharper still, and Aristotle had made it. Number counts units, and where there is no unit, there is no number. To call nothing a number was, in that framework, roughly like calling silence a chord. So the difficulty is not that people were slow. The difficulty is that 0 requires you to change what you think a number is. It has to stop being an answer to how many, and start being something more abstract. A position on a line, a value in a slot, a thing that obeys rules. And once you make that shift, once numbers are objects that behave according to laws rather than tallies of stuff, the door swings open for everything else in this book. Negatives. Irrationals. Imaginaries. Infinities of different sizes. All of them are numbers that count nothing. 0 is the first citizen of that country. Getting it admitted required someone willing to say, the absence of quantity is itself a quantity. The setting matters, so let me sketch it, briefly and honestly. Indian mathematics of this period was written in verse. Not as decoration, as engineering. Manuscripts rotted in the climate, copying was expensive, and the reliable storage medium was a human memory. So the rules of arithmetic were composed in strict Sanskrit meter, terse and rhythmic, and designed to be learned by heart and carried in the head. And the great textbooks were poems. A prose commentary, often by a later mathematician, unpacked what the compressed verses meant. It was also, overwhelmingly, in the service of astronomy. Indian astronomers were engaged in a colossal, centuries-long project of predicting the positions of the planets, the timing of eclipses, and the correct dates of ritual. And this required arithmetic at a scale most cultures never touched. Their cosmology helped. It worked in enormous cycles, world ages counted in the millions and billions of years, and a tradition whose scripture routinely handled such numbers had every reason to want a notation that scaled gracefully, rather than collapsing into a forest of symbols. Sanskrit had names for the powers of 10 running far past anything Greek or Latin offered. Whether the metaphysics also helped is a question people love to ask, and it deserves the same caution I gave the yin-yang argument in the last chapter. The Sanskrit word that came to mean zero is Śūnya, empty, void. It is the same root as Śūnyata, the concept of emptiness that sits at the center of Buddhist philosophy. Not mere absence, but a positive and analyzable feature of reality, something you can think about. It is genuinely tempting to conclude that a civilization already accustomed to treating the void as a subject rather than a whole would find it natural to treat nothing as a number. Tempting and possibly true. But it is also the sort of explanation that is very easy to construct after the fact and nearly impossible to test, and the mathematicians themselves do not say it. I pass it to you as a suggestion, not a finding. What is not in doubt is that by the 6th century, Indian mathematicians were operating a full decimal place value system and doing formidable things with it. Take Aryabhata, who wrote his masterwork in 499 CE, at the age of 23. He produced a table of sign values that is the ancestor of every trigonometric table since the Indian sign function, Jaya, which will pass into Arabic, get mangled by a Latin translator into a word meaning bayrefold, and reach you as sine. He gave a value for pi of 3.1416, which is impressive. But the thing I find remarkable is a single word attached to it. He called it approximate. He did not claim to have found the ratio. He said this was close, and said so explicitly, which means he understood something about the number that had escaped almost everyone before him. He also proposed that the Earth rotates, and that the apparent wheeling of the stars is the consequence, offering the analogy of a boat moving downstream, from which the trees on the bank appear to slide backward. This was not the consensus, and later Indian astronomers argued with him about it for centuries. He was right. Now to Brahmagupta, and to the year 628. He was about 30, working in Balamala, in what is now Rajasthan, and he composed a large treatise on astronomy whose title means roughly the correctly established doctrine of Brahma. Most of it is about planets and eclipses, and the mathematics they demand. But in chapter 18 he stops to lay out the ground rules of arithmetic itself, and what he writes there had never been written anywhere on earth. He organizes it around 3 kinds of quantity. There are fortunes, what you own, what we would call positive. There are debts, what you owe, the negatives, and there is Cipher, Śūnya, 0. Then he states the laws governing all 3, in verse, as flatly as a man reciting a recipe. A fortune plus a fortune is a fortune. A debt plus a debt is a debt. A fortune and a debt together make their difference, and if they are equal, they make 0. 0 added to anything leaves it unchanged. Then subtraction, and here comes the first genuinely radical line. A debt subtracted from 0 is a fortune. A fortune subtracted from 0 is a debt. Read that again, because it is the definition of a negative number, stated in the 7th century, in a form that would satisfy a modern algebra textbook. 0 is not merely the empty slot anymore. It has become the pivot, the hinge in the middle of the number line, the mirror across which every quantity has a reflection. You get the negatives by reflecting the positives through the nothing at the center. That geometry, the number line running out in both directions from 0, is now so basic that it is painted on the wall of every primary classroom. It starts here. Then multiplication. A fortune times a fortune is a fortune. A fortune times a debt is a debt. And a debt times a debt is a fortune. Negative times negative is positive. The rule that has bewildered schoolchildren for 400 years, stated in 628 CE without a flicker of anxiety, as one line among many. Europe would still be arguing about whether negative numbers exist at all 1,000 years later. And here is Brahmagupta calmly telling you the sign rule for their products. He does not justify these rules with proofs, and he does not defend them philosophically. He states them, the way you would state that a week has 7 days. The debt and fortune language does most of the persuading. If you owe money and I cancel your debt, you are richer, and everyone has always understood that. Brahmagupta's move is to notice that this commercial common sense is not a metaphor. It is arithmetic, and it can be written down as law. And 0 in all of this is doing real work. It is not marking an empty column. It is a quantity being added, subtracted, and multiplied like any other. It has been promoted. Then he comes to division, and the whole magnificent structure walks straight into a wall. He begins well enough. 0 divided by any ordinary number, he says, is 0, which is correct, and which is a stranger claim than it looks. But then he writes that 0 divided by 0 is 0, which is not correct. And when he reaches the real question, what happens when you divide an ordinary number by 0? He does something interesting. He declines to answer. He says only that such a quantity is a fraction, with 0 for its denominator, and leaves it sitting there on the page, unresolved, like a box nobody wants to open. This is, I think, an underrated moment of good judgment. He knew something was wrong. He could not say what, so he wrote down the situation and stopped. Others were less restrained. 2 centuries later, the mathematician Mahavira asserted flatly that a number divided by 0 remains unchanged. It is a tidy answer, and it is wrong in a way that would demolish arithmetic if he believed it. And then, in the 12th century, comes Bhaskara, usually called Bhaskara II, to distinguish him from an earlier mathematician of the same name, and he gives the most beautiful wrong answer in the history of the subject. He proposes that a quantity divided by 0 is kahara, an infinite quantity. The word carries the sense of a fraction whose denominator is the void, and it comes from the same root Aryabhata had used centuries earlier for the empty place, and Bhaskara, in defending it, reaches for an image that I find genuinely stirring. Such a quantity, he writes, is unchanged by anything you add to it or take away from it. Just as the infinite and unchanging God is unaltered, the worlds are created and destroyed and multitudes of beings enter into and issue out of him. Set aside for a moment that it is wrong. Look at what he has noticed. He has observed that this quantity, whatever it is, does not behave like other numbers. That adding to it does nothing. That it absorbs whatever you throw at it. That is a real property of infinity, arrived at 700 years before anyone would work out how to reason about the infinite safely. And Cantor's transfinite arithmetic in chapter 20 will confirm the instinct even as it corrects the details. But Bhaskara also wrote other things about this quantity that cannot all be true at once, in particular, that if you take a number divided by 0, and multiply it back by 0, you recover the original number. Follow that rule, and you can make any number equal any other number. He had found a monster and tried to keep it as a pet, and it did what monsters do. So let me tell you what the answer actually is, because it is short, it is decisive, and it is a lovely example of how mathematics closes a question. Ask yourself what division means. When we say that 12 divided by 4 is 3, what we are really saying is, 3 is the number that, multiplied by 4, gives 12. Division is not an independent operation. It is multiplication run backwards. A divided by b is a request : find me the number that, when multiplied by b, yields a. Now put 0 in the denominator. 6 divided by 0 is a request to find the number that, multiplied by 0, gives 6. There isn't one, not because we haven't looked hard enough, because everything multiplied by 0 is 0. That is not a limitation of our imagination, it is what 0 is. The request has no answer, and can have none, in the same absolute way that the diagonal of the square has no ratio. And the special case is stranger still. 0 divided by 0 asks for the number that, multiplied by 0, gives 0. Now, every number in existence qualifies. 7 works. 1,000,000 works. Every single one. So the two cases fail in exactly opposite ways. One question has no answers. The other has all of them. And a division that returns nothing, or returns everything, is not a division at all. Because the whole point of an arithmetic operation is that you put numbers in and get one number out. 0 breaks the machine from both directions at once. That is why mathematics does not say that division by 0 is infinity. It says the expression is undefined, which is not a shrug, and not a confession of ignorance. It is a decision, and a load-bearing one. Allow division by 0 into your arithmetic and you can prove in 3 or 4 lines that 1 equals 2, and from there that every number equals every other. And the entire subject collapses into a pile of rubble in which nothing can be distinguished from anything. The door is not closed because the thing behind it is frightening. It is closed because it is not a door. It is a wall, and the building is standing on it, which gives me a chance to say something this book needs, and to say it here rather than let you discover it as a disappointment later. The story I have been telling you has a shape. Mathematics meets the impossible, recoils, and eventually opens the door. The unspeakable diagonal became a number. Nothing became a number. Debts became numbers. Every chapter so far has ended with a monster domesticated and handed to children. But not every monster gets in. Some impossibilities are permanent, and this is one of them. And the distinction between the two kinds is the most important thing an educated person can understand about how mathematics grows. The difference is this: when mathematics admitted the irrationals, and zero, and the negatives, and later the imaginaries, nothing broke. Everything that had been true before remained true. The old arithmetic sat inside the new one, unharmed, like a room inside a larger house. Expanding the system cost nothing. That is exactly why the expansion could happen. The monster turned out to be compatible with everything already standing. Division by zero is not like that. It cannot be admitted without destroying what is already there. You can define new systems in which something like it exists. Mathematicians have built such things, and they are used in computer arithmetic and in certain branches of geometry, but you always pay. And what you pay with is some of the ordinary arithmetic you were trying to protect. There is no free version. So the honest formulation of this book's thesis is not that mathematics can absorb anything. It is that mathematics is ruthlessly experimental about what it can absorb. It tries the door. If the house still stands, the monster stays and eventually gets a chapter in a textbook. If the house falls, the monster is turned out permanently, and the failed attempt is written up as a theorem about what cannot be done. And notice, finally, that the wall was still worth walking into. The question Brahmagupta declined to answer, and Bhaskara answered wrongly, does not go away. It becomes the most productive question in the history of mathematics. What happens to a fraction as its denominator gets smaller and smaller, closer and closer to zero without ever arriving? Not at zero. Approaching zero. That question is the seed of the limit, and the limit is the foundation of calculus. And calculus is the machinery that describes every falling body, every orbit, every current, every rate of change in the physical world. Bhaskara was pointing at something real. He simply named the journey after a destination that does not exist. Now watch the word travel, because its root is the root of the numerals themselves, and it ends somewhere you would not guess. The Sanskrit is Śūnya, empty. When Indian mathematics reached the Arabic-speaking world, translators did not merely borrow the sound. They translated the meaning, which is a much more intimate kind of adoption. They rendered it as ṣifr, the Arabic word for empty. Centuries later, when Arabic mathematics reached Latin Europe, ṣifr came too, and then it split in half. One branch was hammered into Latin as zephyrum, softened in Italian to zeffiro, and clipped down to zero. The other branch stayed closer to the original sound and became cifra, which gives Spanish cifra, French chiffre, German ziffer, and English cipher. And here is the odd part. In several of those languages the word came to mean not zero specifically, but any digit at all. Because to Europeans' first encounter in the Hindu-Arabic numerals, the whole strange set of squiggles was foreign and unreadable, and the name of the strangest one got applied to all of them. From there it acquired its other English meaning. A cipher is a secret code, something written in symbols outsiders cannot read, which is precisely how these numerals looked to a European merchant in 1300. Zero and cipher are the same word, split at the border, and sent down different roads. And decipher, to work out what an unreadable text says, is the fossil record of the moment Europe met Indian arithmetic and could not read it. That meeting is where we are going next, and it happened first in Baghdad. The traditional account says that around 771 CE, an embassy arrived at the court of the Caliph Al-Mansur, and among its party was a scholar carrying an Indian astronomical treatise. The Caliph ordered it translated into Arabic. The resulting text and the tables of planetary motion it contained brought Indian methods, and the Indian numerals, and the zero into the intellectual bloodstream of the Islamic world. The story comes to us through later Arabic sources rather than contemporary ones, so treat the details as tradition rather than record. But something very like it certainly happened, because within a couple of generations, mathematicians in Baghdad were working fluently with the Indian system, writing books to explain it and improving on it. And one of them, in the 9th century, would write a treatise on solving equations whose title contains the word algebra, and a book on Indian calculation whose Latinized version of his name would come to mean a step-by-step procedure guaranteed to produce an answer. He gave us both algebra and algorithm, and he worked in the greatest research library the world had yet seen. One last thought before we leave. Look at a keyboard. Look at a phone screen, a price tag, a clock, a page number, a bank balance, a line of computer code. 0 is everywhere, and it is invisible, in the way that only genuinely fundamental things are invisible. The entire digital world runs on a number system with exactly 2 symbols, and one of them is nothing. A 7-year-old handles it without a flicker. She will tell you, if asked, that 0 is what you have when you have none, and she will not find this paradoxical in the slightest, and she will be annoyed at you for asking such an obvious question. It took our species 3,000 years of written arithmetic to reach the point she starts from. That is the pattern. Again. And it will keep happening. The thing that could not be a number, then became so ordinary that its strangeness is invisible even to the people using it 100 times a day. 0 is the most successful monster in this book. It got so thoroughly domesticated that we forgot it was ever wild.